Hello and welcome back everyone to a brand new module in Python programming. In previous modules of the course, we focused on the basics and intermediate topics in Python programming. Going forward, we're going to be focusing on much more advanced content. We'll be working with popular Python programming libraries. In today's lesson, we're going to be working with multidimensional data. Now, before we dive into today's lesson, let's take a moment to review the objectives. First, we'll define multidimensional data. Next, we'll move on to exploring the applications of multidimensional data in Python programming. And then finally, we'll wrap things up with a practical demonstration. Now, the first question that comes to mind is, what exactly is multidimensional data? Now, dimensional data, also known as multidimensional data, refers to data that can be organized and analyzed in multiple dimensions or axes. This type of data is commonly used in business intelligence and data warehousing applications, where data is often stored in a multi-dimensional database. Now, a simple example would be if you have sales data for a company, you might organize it by product, region, and time. And the data would be organized into a three-dimensional cube. You could then slice and dice the data along any of those dimensions to analyze it in different ways. Now, given that somewhat long-winded explanation, with the previous example in mind, consider the following cube. Dimensional data is typically contrasted with relational data, which is organized into tables with rows as well as columns. Relational databases are well suited for transactional data, but can be less efficient for analytical processes. Dimensional data, on the other hand, is designed to support fast and flexible analysis of large volumes of data. Now, when it comes to multidimensional data, there are a couple of characteristics that one must take into account. The first is the most obvious, and that is the dimensionality of the data. One must also take into account the complexity of the data as well as the sparsity. With multidimensional data, there tends to be a high degree of correlation among the dataset. And lastly, one must also take into account the data quality. Now, here are some interesting applications of dimensional data. The first is data warehousing, where we collate massive amounts of data sets into one specific location so that that data can be mined at a later stage. We can also use dimensional data for computer vision systems, as well as machine learning applications. Now, let's take a look at a simple example of how to access a dimensional object in Python using code. First, we create a variable called payload. We then instantiate an array, and inside of that array, we have another array or a list. Notice that this is set at index 0. Likewise, we have a second list at index 1, and lastly, we have a third list at index 2. We then move on to printing our payload object, and at index 0, we would get the output of the first list. That is to say, with a list of integers that include 23, 10, and 15. We can take this a step further. If we print the payload with two indexes being referenced, notice that at index 1 we target the second list, and within the second list we target the second index, which would output the integer 78. Now, I know that staring at a code snippet with a bunch of animations really doesn't provide any sort of meaningful context. So, without further ado, let's dive into a practical demonstration and let's try to make a bit more sense of dimensional data. To get started with our practical demonstration, we are first going to explore some of the concepts that we are already familiar with. And that is to work with an iterable object, otherwise known as an array. So I'm simply going to create a variable called payload over here. I'll set this equal to the following values in my array. The first one will be 23. I'll add 10, 15, 20, and lastly, I'll add 13. Now, this is what is known as a one-dimensional array or a 1D array, and that is because this is a flat object. And we already know that if we simply go ahead and print out some values, we can print out the index of our payload array, and I'll target the first one at index 0. We know we are going to produce the number 23. So if I run this code, I should see 23 in my output. Likewise, if I copy and paste this and I decide to opt for index number 3, we can expect to see the number 20. So let's run this again. And we have 23 and 20. So we know that this is a 1D array. What are some of the advantages of multi-dimensional data? Well, now we can start talking about 2D arrays and then 3D arrays. So what does that example look like? Now on a new line over here, I'm going to create a payload, and I'm going to call this payload number 2 so that we can differentiate between the first payload and the second payload. I'll set this equal to, and this is one thing that one should take note of. I'll start with a square brace, and then I'll just provide a bit of real estate over here. And now inside of this array, I'm going to create another array. So I'll do another square brace over here. I'll do 23, 10, and 15. And then I'll add another array inside of the first array object that we created over here. So in essence, what we have is a list of lists, if that makes sense. So I'll open up with another square brace over here. I'll do 35. I'll do 59. And 78, and then I will create 2 more, and I'll create another list inside, or another array inside, and I'll do 100. I'll move on to 12 and 95. Great. Let's create one more array, and over here I'll start off with another square brace. I'll do 30. I will do 11, and I'll add 52 to the last index over here. So let's just quickly take a moment to review our code. We've opened up an initial array over here. Inside of that array, we created various other array objects. And again, this is what is known as a 2D array. Now, if I print out the payload at the bottom over here, let's maybe just comment this out. And then on a new line, I'll simply print out the payload 2 object. So I'll print payload 2. And if I run this now, we'll get the exact replica of what we have over here. But let's say, for example, I wanted to access the second array within this array over here. Well, then I could simply do something like payload, and I would add 1 over here. And that would retrieve this index over here. The first index, because this index is 0, and this is the second index, but this in actual fact is the first index, because do keep in mind, computers do not count from 1, they count from 0. So now that we've retrieved this object over here, what if we wanted to retrieve the value 78 within this object, within our 2D array? Well, then I can tack on another piece of code over here, and I'll simply pass in the index number 2 over here. So if I run this code now, I should retrieve 78. And that is because we first call this index over here by referencing the first index over here in our payload code. And then within that object, since we are within the first index over here, this entire object, we then decided to tap into that object and retrieve the second index, which is 78. So let's say, for example, we wanted to retrieve the number 30 from our 2D array. Well, then we can just make minor changes to our code. So over here, I'm going to pass in 3 as the index to target this array over here. And then I'm going to pass in 0. And that's going to allow me to retrieve 30 over here. And there we go. Likewise, let's do one more example. I'll target this one over here. And this is index number 2, this array object over here. And I'm going to try to retrieve the number 100. Likewise, I can maintain the 0 over here because this is the 0 index of the second array object. And if I run this now, I have 100. Great. So that's 2D arrays. Let's take things one step further and let's explore 3D arrays. Now, for the most part, 3D arrays follow the exact same principles as 1D and 2D arrays. However, they are a little more complex, and that's because we are adding more dimensionality to our array object. So on a new line over here, I'm going to create payload number 3. I'm going to set this equal to a set of square braces. What I'll maybe do is just delete all of the previous code we had. And inside of this, I'm simply going to create a new array object once again. And within this array object, I'm going to go one level deeper, and I'm going to create our array lists with the actual numbers. So I'll do 1, 2, and 3. And within this array over here, as we can see the square braces being highlighted, I'm going to create yet another array object. So I'll do 4, 5, and 6. And then we'll do one more. and that's going to be 7, 8, and 9. Great. So now we have an array, and inside of this array, we have another array, and inside of that array, we have another array. So we're going 3 levels deep into this array. At the end of this array, I'm going to add a comma, and I'm going to copy and paste some code. And the goal here is to just basically save a bit of time, of course. So let's just provide some real estate over here. And what you're looking at now is 3 separate arrays within arrays within arrays, if that makes sense. So let's say we wanted to grab the number 14 over here. Well, then I can simply just do a print, and I'll print the payload 3, and I'm going to target the first array or the first index, and that's going to target this array over here. If I run this code, we should see this exact code. So we can actually see this maps out perfectly. But now I want to go 1 level deeper. Inside of the first index, I want to target the first object, which is this one over here. So to do that, I can simply just tack on 1 yet again. And if I run this code now, I should retrieve this object over here. So if I run this again, we can see 13, 14, and 15. And once again, I'll tack on 1. And that's because I want to go yet another level deeper so that I can grab the value 14 over here. And there we go. Works perfectly. Let's just clean up our code a little over here so that we can get rid of all these squiggly lines. Great. So let's assume we wanted to target the third array over here. Well, to do that, I can simply just change the index here to 2. And if I wanted to target this object, this array object over here, well, then I can simply just write 2 once again. And let's say within this object, I wanted to target the value 25. Well, then I can just tack on 0 over here. And there we go. Now you might be asking, why would you go through the effort of actually learning how to work with multi-dimensional data? Well, the answer is actually very simple. When it comes to computation, we've worked with SQL databases before, which allows us to transact with databases and retrieve values and manipulate data. But when working with arrays, for example, in the event that you are building neural networks or you're working with machine learning and you want to train a model, this approach, working with data in this specific approach, or working with data in this fashion where we use multidimensional data, tends to be a lot more efficient and a lot quicker for computation. And that is why it's so important to understand the concepts of multidimensional data. So in today's lesson, we learned all about dimensional data. We learned all about how to work with 1D arrays, with 2D arrays, as well as 3D arrays. We also learned how to query our arrays in the event that we want to get specific data from our array. In our next lesson, we are going to work with a Python library that makes working with dimensional data somewhat easier. So for all of that and more, I'll see you in the next lesson. Cheers.